Welcome back to part 3 of going through all of the documentation for VisionOS. We're moving on to designing for VisionOS. This is a separate page, it's not an article. Here is how it looks. We're designing for VisionOS. When people wear Apple Vision Pro, they enter an infinite 3D space where they can engage with your app or game while staying connected to their surrounding. As you begin designing your app or game for VisionOS, start by understanding the fundamental device characteristics and patterns that distinguish the platform. Use these characteristics and patterns to inform your design decision and help you create immersive and engaging experience. The first characteristic and pattern is space. Apple Vision Pro offers a limitless canvas where people can view virtual content like windows and volumes and 3D objects, and choose to enter deeply immersive experiences that can transport them to different places. Second, immersion. In a VisionOS application, people can fluidly transition between different levels of immersion. By default, an app launches in the shared space where multiple apps can run side by side and people can open and close and relocate windows. People can also choose to transition an app to a full space where it's the only app running. While in a full space application, people can view 3D content blended with their surroundings, open a portal to view another place, or enter a different world. Third, pass-through. Pass-through provides live video from the device external cameras and helps people interact with virtual content while also seeing their actual surroundings. When people want to see more or less of their surroundings, they can use the digital crown to control the amount of pass-through. Fourth, spatial audio. Apple Vision Pro combines acoustics and visual sensing technology to model the sonic characteristics of a person's surrounding, automatically making audio sound natural in their space. When an app receives a person's permission to access information about their surroundings, it can fine-tune spatial audio to bring custom experiences to life. Eyes and hands. In general, people perform most of by using their eyes to look at virtual objects and make an indirect gesture, but like a tap to activate it. People can also interact with a virtual object by using a direct gesture like touching it with a finger. Ergonomics. While wearing Apple Vision Pro, people rely entirely on the device's camera for everything they see, both real and virtual, so maintaining visual comfort is paramount. The system helps maintain comfort by automatically placing content so it's relative to the wearer's head, regardless of the person's height or whether they're sitting, standing, or lying down. Because VisionOS brings content to people instead of making people move to reach the content, people can remain at rest while engaging with apps and games. Accessibility. Apple Vision Pro supports accessibility technologies like VoiceOver, switch control, dwell controls, guided access, head pointers, and many more, so people can use the interactions that works for them. In VisionOS, as in all platforms, system-provided UI components build in accessibility support by default, while system frameworks give you a ways to enhance the accessibility of your app or game. Okay. In summary, here are the characteristics of VisionOS, Vision Pro that we should consider. Space, immersion, pass-through, spatial audio, eyes and hands, ergonomics, and accessibility. It sounds like we're going to design our app around a sedentary movement. Basically, people are not moving. And then we want to design it so that it's easy for people to feel the immersion using space, immersion pass through, spatial audio. You want to give them a very immersive experience, and you want people to interact easily with their eyes and tap with their hands generally. And you want to bring things close so that people can directly touch them. As for accessibility, it sounds like we should definitely add these technologies to our apps so that more people can interact more easily with the app that you create. Okay, I think I'm going to stand corrected as we go into the best practices. So great VisionOS apps and games are approachable and familiar while offering extraordinary experiences that can surround people with beautiful content, expanded capabilities, and captivating adventures. Embrace the unique feature of Apple Vision Pro, take advantage of spatial audio, and immersion to bring life to your experiences, while integrating pass-through and spatial inputs from your eyes and hands in ways that feel at home on the device. Consider the entire spectrum of immersion as you design ways to present your app most distinctive moments. You can present experiences in a windowed, UI-centric context, a fully immersive context, or something in between. For each key moment in your app, find the minimum level of immersion that suits it best. Don't assume that every moment needs to be fully immersive. That's an interesting statement that we should like try to bring the minimum immersion as possible for our app or for our experience. That way, I think people will feel more at home with their surroundings. I think that's the idea. So use Windows for contained UI-centric experiences to help people perform standard tasks. Prefer standard windows that appear as planes in space and contain familiar controls. In VisionOS, people can relocate windows anywhere they want, and the system dynamically scaling helps keep window content legible, whether it's near or far. Prioritize comfort to help people stay comfortable, physically relax as they interact with your app or game, and keep the following fundamentals in mind. Display content within a person's field of view, position it relative to their head, avoid placing content in places where people have to turn their head or change their position to interact with it. Avoid displaying motion that's overwhelming, jarring, too fast, or missing a stationary frame of reference. Support indirect gestures that let people interact with apps with their while their hands rest in their lap or at their side. If you support direct gestures, make sure the interactive content isn't too far away and that people don't need to interact with it for extended periods of time. Avoid encouraging people to move too much while they're in a fully immersive experience. Help people share activities with others. When you use share play to support shared activities, people can view the spatial personas of other participants, making it feel like everyone's together in the same space. And so it corrects me on a few points about how we should, uh, you know, design apps. It looks like we had a few of these correct. Field of view, indirect gestures, keeping things close when they're direct gestures, and make sure people are able to use indirect gestures by using their eyes and taps with their hands in a very sedentary motion position. However, we should avoid displaying motion that is overwhelming and drawing too fast. I think that is for just keeping people comfortable. Most of it sounds like most prioritize comfort. It's like we want to keep people comfortable and so that you can use your app for long periods of time. I think that's the idea here. Just comfortable things that people find comfort in, so that they're the apps in the space. You don't have to really worry about it. It's just kind of in the background. Same with the using Windows for containing UI-centric experiences for, I guess, UI is user interaction. Whenever when the user wants to interact with something, just make sure there's a window that helps people perform standard tasks. It's all about comfort. It looks like the design and the comfort and immersion, like I said before. Okay, with that, we can now move on to the next bit of design, which is adopting best practices for privacy and user preferences. All right, here we want to minimize your use of sensitive information and provide a clear statement of what information you do use and how you use it. We want to protect user privacy. The information handles the camera and sensor inputs without passing the information to apps directly. Instead, the system enables your app to seamlessly interact with a user's surrounding and to automatically receive input from the user. For example, the system handles the eye and hand position data needed to detect interactions with your app content. Similarly, the system provides a way to automatically alter a view's appearance when someone looks at it, without your app ever knowing what the user is looking at. In the few cases where you actually need to access the hand position or information about the user's surroundings, the system requires you to obtain authorization from the user first. Here in this screenshot, we are asking the user for hand structure and movement to track your hands to detect a heart gesture in this happy beam game. Right, here's another piece of information to warn us about privacy. It is your responsibility to protect any data your app collects, and it's to use it in a responsible and privacy protecting, preserving way. Don't ask your data, don't ask for your data that you don't need. Be transparent about how you use the data you acquire and respect the choices of the person whose data it is. Here, we can ask for more information about the specifics of privacy data and describing data use in privacy manifests. And for general information about privacy, see protecting the user's privacy. It's just telling us that use and collect the data that we need so that the user is more comfortable. It's all about comfort. Let's look at the next bit. Adopt the system provided input mechanism. On Apple Vision Pro, people uses their eyes, hands to interact with the items they see in front of them. Where they look determines where the system applies focus, and a tap gesture with either hand generates a touch event on that focus item. The system can also detect when someone's finger interact with virtual items in the person's field of view. When you adopt the standard UI kit and Swift UI event handling mechanism, you get all of these interactions automatically. For most apps, the system provided gestures recognizers are sufficient for responding to interactions. Although you can get the position of someone's hands with ARKit, doing so isn't necessary for most apps, collecting hand position data only when the system does not offer what you need. For example, you might want to use hand position data to attach 3D content to a person's hands. Some other things to remember about hand position data is that people can't deny your request for accessing the hand position data. Be prepared to handle these situations where data isn't available. You must present an immersive space to access hand data. When you open immersive space, the system hides other apps. So for more information about how to handle standard system events, see Swift UI and UI kit documentation. We want to use standard system events. We want to use those event handling mechanisms for people to interact with our app. It makes people feel comfortable and they don't have to learn anything new. Let's start with those first. Those are necessary because in the case where you can't collect hand position data, they won't be able to use your app. Provide clear messaging around privacy-sensitive features. The following ARKit feature requires you to provide a usage description string in your app info plist file, world tracking data, and hand tracking data. Other privacy-sensitive technologies in VisionOS also requires you to supply usage description strings. For example, you provide usage descriptions for the core location features you adopt. These strings communicate why your app needs the data and how you plan to use the data to help the person using your app. The first time you request authorization to use the technology, the system prompts the person to grant or deny access to your app. The system includes your usage description string in the dialog it displays. That's very similar to any iPhone app you create where you have to ask for sensitive privacy information. For information about requesting access to ARKit data, see ARKit. For a guidance on how to craft a good message around privacy-friendly features, see Human Interface Guidelines. I think, personally, you should definitely test what you want to do then take a look at the human interface guidelines and correct it as necessary. All right, let's move on to improving accessibility support in your VisionOS application. VisionOS app. Update your code to ensure everyone can access your app content in VisionOS. This is another design article about improving accessibility. VisionOS is an immersive platform that supports people of all abilities. Even though experiences incorporate stunning visual content and high and hand and eye tracking technologies, people can engage with content in other ways. In fact, the platform supports people in many different situations, including those who are blind, have low vision, have limited mobility, or have limb differences. With the help of assistive technology, people can interact with all of your app content. Let's watch this little video, what they want to show
Heavy
us.
beam. 3 clouds above and in front of you to the right. Direct gestures enabled. Press the crown to exit. Casting beam. Grumpy cloud hit. Hiding beam.
It looks like what happened over here was during development, enable voiceover and other assistive features and test your app accessibility support. Make sure people can navigate your app interface intuitively and that all of your necessary elements are present. Improve the descriptive information for those elements to communicate their intended purpose, and make sure your app adopts to changing conditions, such as changes to the dynamic type settings while your app is running. Okay, here is dynamic typing. We want to make sure that based on the dynamic type that was given to our app, we want to increase the font size and the image size, it looks like. Well, except here it just increases the font size. For general information about supporting accessibility, see accessibility. For design guidance, use human interface guidelines and accessibility. Wow, we get some code. All right, add accessibility traits to RealityKit entity. VoiceOver and other assistive technologies rely on the accessibility information that your app views and content provides. SwiftUI and UIKit provide default information for standard system views, but RealityKit does not provide default information for entities in your scene. To configure the accessibility information for a RealityKit entity, add an instance of accessibility component to the entity. Use this component to specify the same values you specify for the rest of your app views. The following example shows how to create this component and add it to an entity. Here is an accessibility component. We take this component, set it true, .traits, set it to button, label, and we set it to sports car, value, parked, system action, .active, and we set this particular entity's components to accessibility components. Okay, all right, very cool. People can use VoiceOver to initiate specific type of actions on your entity. Assign a value to the system actions property of your components if your entity supports the incrementing or decrementing of its values, or support activation with a gesture other than a standard tap. You don't need to set a system action if you let people interact with the entity using a standard a single tap gesture. The following example uses the content of a reality view to determine when activation event occurs on the view's entity. After subscribing to the view's activation event, the code sets up an asynchronous task to handle incoming events. When a new event occurs, the task executes the custom code to handle a collision. Here's a activation subscription content.subscribe to our accessibility events.activate. Upon activation, we do a handle collision, and during that collision, we have activation entity and the game model. Okay, very cool. So I think this has to do with the Happy Cloud code, where we handle the collision of the Happy Beam and the cloud, where The accessibility events occur, which is not it's not for Happy Cloud. Sorry, it's for the sports car that's parked. Okay, add support for direct gesture mode. When VoiceOver is active in VisionOS, people use hand gestures to navigate your app interface and inspect elements. To prevent your app code from interfering with VoiceOver interactions, the system does not deliver hand inputs to your app during this time. However, a person can perform a special VoiceOver gesture to enable direct gesture mode, which leaves VoiceOver enabled but restores hand input to your app. Add voiceover announcements to your code to communicate the results of a meaningful message. VoiceOver speaks these announcements at all times, but they are particularly useful when direct gesture mode is turned on. The following example posts an announcement when a custom gesture causes an interaction with a game piece. Accessibility notification announcement game piece hit post. Okay. Um yeah, I this piece of code doesn't tell me exactly how you turn off how you enable direct gesture mode and a special voiceover gesture. Maybe it does. We'll have to look more deeply into the code to understand how exactly this works. Okay, next piece. Provide alternative to inputs that involves physical movements. Reduced mobility can affect a person's ability to interact with your app's content. When designing your app input model, avoid experiences that require specific body movements or positions. For example, if your app supports custom hand gestures, add a menu command for each gesture so someone can enter them using a keyboard or assistive device. Some assistive technologies let people interact with your app using only their eyes. Using these technologies, they can select, scroll, long press, drag items in your interface. Even if you support other types of interactions, give people a way to access all of your app's behaviors using only these interactions. Earlier, we were talking about voiceover and how to add those components into a reality kit entity. And now we then looked into direct gesture mode to work on voiceovers. Now we're looking into alternative inputs for people who have physical mobility, um, have reduced physical mobility. So here we want to give everyone, we want to manufacture our app to for eye use, purely eye use without the usage of hands, and make sure that experience is possible. Next, avoid head-anchored content. Some assistive technologies allow people to navigate or view your app interface using head movements. As the person's head moves, the assistive technology focuses on that item directly in front of them. Content that follows the movements of the person's head interferes with the behaviors of these assistive technologies. When designing your interface, place content in windows or anchor it to locations other than the virtual camera. If you do need head anchoring content, provide an alternative solution when relevant assistive technologies are in use. For example, you might move head anchor in content to the anchor point that does not follow the person's head movements. Determine when to change the anchor approach for your content. Check accessibility preferred head anchor alternative environment variable in SwiftUI or AX prefer head anchor alternative function. This environment variable is true when an assistive technology is in use that conflicts with head anchoring content. Adapt your content to use alternative anchoring mechanisms at that time. All right, if you have head anchoring content, then you want to anchor it to something else under a different circumstance. So that means you have to support, if you have this particular type of entity is head anchor, then you need to provide an alternative to that, like place it on the ground or place it um, on the feet, maybe something else, anything other than the head anchor. The reason why we want to make sure that because people use their head as a input, head movement as an input, and by putting this this um this interferes with the assistive technology, as you can see, and so we need to place it somewhere else. maybe the well, if they have hands, then we place it on the hand. If they don't have hands, then I guess we need to place it on their feet, or like something that's anchored to the body, maybe, um, but not the head movement. Limit motion effect in your content. Motion effect on any immersive device can be jarring even for people who aren't sensitive to motion. Limit the use of motion effects that incorporate rapid movement, bouncing, or wave-like motions. Zooming, animations, multi-axis motivation, movements, spinning, or rotations. When the person wearing the device is sensitive to motion effects, eliminate the use of these effects altogether. The reduce motion system setting lets you know when to provide alternatives for all of your app's motion effects. Access this setting using the accessibility reduced motion environment variable in SwiftUI or is reduced motion enabled property in UIKit. When the setting is true, provide suitable alternatives for motion effects or eliminate them altogether. For example, show a static snapshot of the ocean instead of a video. For example, see human interface, guidelines, and motion. All right, so what is seen here is that if you have content that has motion, you should handle situations where people have the accessibility reduced motion environment variable set to true. And that way, you can turn off the motion and provide a limited motion effect for the users who want to reduce motion. Include captions for audio content. For people who are deaf or hard of hearing, provide high quality captions for your app content. Captions are a necessity to some, but are practically for everyone in certain situations. For example, captions are useful to someone watching a video in a noisy environment. Remember to include captions not just for text and dialogue, but also for music and sound effects in your content. For spatial audio content, include information in your caption that indicates the direction of various sounds. AV-Kit and AV Foundation provides built-in support for displaying caption content. These frameworks configure the font, size, color, and style of the caption automatically according to the person's accessibility settings. For example, the framework adopts the current dynamic type settings when displaying text. If you have a custom video engine, check the is closed captioning enabled accessibility setting to determine when to display caption. To get the correct appearance information for your caption content, adopt media accessibility in your project. This framework provides you with the optimal font, color, opacity information to apply the caption text and images. Okay, whenever we have audio content, let's add some captions to be more inclusive of everybody. Here we are working for people who have hard of hearing. Here we are working for people who have limited mobility or reduced mobility. Here we work with people with hard of vision. Was it hard of vision here? Yes, it's hard of vision. So we provide the voiceovers. And once we cover all of these bases, we will have a very accessible app for everybody. So make sure to go through these steps to make sure your code, your VisionOS app is accessible by everybody. And with that, we have gone through 3 design articles. One is designing for VisionOS, basically make it a comfortable experience. That's a sedentary. Second, adopt best practices for privacy. Make sure you ask the user for hand tracking or world tracking data for your reality kit. AR kit, sorry, AR kit. And lastly, we want to add accessibility to our Vision OS app so that users can have an alternative experience of the application. Next, I think we'll finally go into some code with Swift UI and look at the Hello World application.